data collection experiment. We would employ two methods of drone data collection and then compare and contrast the results.
Here we have the Memorial Tower in the heart of LSU's campus, erected in 1923 and officially dedicated in 1926 to all of the veterans who died in World War I.
Normally, a drone flight path is actually directed from a horizontal perspective for the aerial view. For this project, we'll be utilizing a new software function with UGCS, which allows for vertical flight paths. These paths will allow us to develop an orthomosaic from a point cloud, which we will convert into a mesh and then a solid to make a 3D print of our structure of interest, the clock tower.
And that was the start of this project. We would use the new software to create a vertical drone flight plan around the LSU Memorial Tower and collect photographic data. Then create the typical horizontal drone flight plan and again collect photographic data. Next, process the photos through Agisoft Metashape and ArcGIS Pro to create a DSM, a DTM, and an orthomosaic. Finally, we would compare and contrast the two processes and end results for the joy and enlightenment of all.
These are some of the problems which we anticipated running into while collecting data. The people problem was avoided by using standard operating procedures for drones and having a dedicated watcher on the team. One side of the building was difficult to photograph because of intense GPS signal interference. And finally, we had to adjust our schedules a couple of times due to bad weather.
But life often does not go according to plans. Sometimes, surprises appear seemingly out of nowhere. So you take a few moments to reassess, you make a course correction, and you continue boldly forward.
Due to unforeseen circumstances, we were not able to access the UGCS software. So we rerouted our project and decided to render the 3D model using manual vertical flight photos and a few other things. We flew the Paradanafi drone and took photos of each wall of the Memorial Tower and the connecting building, taking care to only take pictures vertically and not from a God's eye view looking down. The Agisoft Metashape software did not know which wall to connect to which, so we returned and took more photos, this time of the corners of the tower and the building. Using these photos and with a little work in Metashape, we were able to create a stable STL file which was then used to 3D print two test models on a Frozen Sonic Mighty 8K resin printer. Unfortunately, we did not have as good of luck in ArcGIS Pro using those same Metashape files. So we built a DSM, a DTM, and an orthomosaic from scratch in ArcGIS Pro. What you're looking at is the result. Even with the photos of the building corners, ArcGIS Pro added an extra side of the building and had holes in the rooftops and walls, which did not occur in the Metashape software. At this point, we've flown the drone a few times to get better photos, including a horizontal or God's eye view path, in an attempt to correct the problems we faced in ArcGIS Pro. The horizontal photos only made things worse, and with the addition of these new photos, the digital surface and terrain models, along with the orthomosaic, were flattened. However, we have shown that it is possible to build 3D models using only vertically taken photographs, and even found a couple of tips in making that process work better. How do we move forward on the project at this point? I dug up some old drone photographs of the LSU campus mounds and the Poverty Point mounds, which were from classes in 2019 that I took, and added them to this project. Here, we see the newly created models in ArcGIS Pro using those old photos of the LSU campus mounds. The orange-colored lines are the flight paths, and the yellow squares are the cameras, or rather where the cameras were when the photos were taken. These photos from 2019, or more accurately, these models created from those photos, can be compared to newer models and used to determine if any slumping or creep has occurred on the LSU mounds over these past several years. This is important now that the mounds are a protected archaeological site. The original photos were taken with the DJI Phantom 4 drone, a relatively expensive model. The newer photos, and all photos taken this year for the project, were with a $300 Parrot Anafi drone. The LSU mound photos were more of a horizontal flight path and from the God's eye view or looking down. The drone, the Anafi Parrot, was manually flown and photos were taken in about 15 minutes time. We now have two models of the LSU mounds at about 4 years apart, which we can now compare and use for future comparisons. Future work for this project includes taking a larger number of photos of both the LSU Memorial Tower and the campus mounds and seeing if that helps with the orthomosaic rendering from the Parrot Anafi. The largest differences between the older drone photos and these new ones are that the older photos were taken from around 100 meters above ground, while these newer photos were taken from 5 to 10 meters above ground, and the older photos were generated automatically from an automated flight path, while these new photos were manually taken from a drone being flown manually. Finally, we have models created of Poverty Point from drone photos taken back in 2019. These models were created along with all the other models in this project using this new ArcGIS Pro. The next step for Poverty Point would be to make a trip there to get new pictures and then create 3D models, DSM, DTM, orthomosaic, and compare these new ones to the ones we've created in this project from 2019.